All right, welcome back, everybody. This is Multi-Cloud Network Architecture Series episode 22. And in this episode, we're going to be talking about an Aviatrix validated design focused on Windows Virtual Desktop. Aviatrix validated designs are put together by our experienced solutions architecture team. These are designs that are currently in production that have been tested thoroughly and are easily consumable via clearly written guides that we post on our doc site. I will post a link in the comment section of this video to this particular Windows Virtual Desktop AVD. So today I've invited two very special guests, Bryan, Ashely, and Manny Calero. Both Bryan and Ashely come to us from the Azure team at Microsoft. They now work for Aviatrix. Bryan and Manny are also Azure Networking Blackbelts. This is a title bestowed upon only the best networking professionals at Microsoft. And now we've got them. I'm really excited to get started on this episode. Bryan, Manny, thank you so much for being here with me today. So Manny, tell me a little bit about what Azure WVD is and what Aviatrix is doing to augment this type of environment.
So WVD is Microsoft's managed service to provide customers with Windows virtual desktops. It has a few components. So there's the managed plane or the control plane, and these are the components that Microsoft actually manages for the customers. And then there's the customer managed side, which is where the host pools are deployed, which is in a regular VNet, as you would know, and as any workload that gets deployed in IaaS in Azure, it would be the same. So the host pools are essentially virtual machines running on a VNet. The provisioning and the spinning up of the virtual machines is actually done by the control plane or the managed service of Microsoft. And that is front-ended, actually advertised, to customers on the internet through Azure Front Door or Traffic Manager.
Got it.
So if we look at the overall design, right, the way that it works is once the host pools or the desktops are deployed in a VNet, the desktops are running an agent which reports itself to the broker. That's how the managed service knows that there's a resource behind it that customers can access through the web access. As you can see, it is a VNet, and you can still access on premises, whether it's through a VPN or through ExpressRoute. And also, obviously, through the internet, remote users can access the web access directly.
Okay, Manny, that's a good explanation. I understand what WVD is now, and I'm assuming this is a pretty widely deployed solution in Azure, which also means that there are going to be challenges out there, and we see a lot of customers coming to us looking for solutions to these challenges. So I'm curious, Bryan, can you tell me a little bit about some of the challenges that our customers are coming to you with?
Yeah, absolutely. So the WVD service itself inherently has some of its own challenges. What Manny's talked about so far is the control plane and the host pools, but often the host pools themselves, which obviously are desktops, have dependencies. So the image that runs on the VM has to live somewhere. That could be something like NetApp files, that could be Azure storage. The desktops typically have to be connected to some sort of domain, which could be Azure Active Directory services or even an on-prem DC. So there's a lot of dependencies that require some level of connectivity. But then even as users get onto the desktops, they have to access apps. And those apps may be in other VNets, they may be in other regions, they may be in other clouds, or even on-prem. In addition to that, often these desktops are divided into host pools, which could be per environment. They could be based on specific applications. And so inherently there is a requirement for security in some fashion. Right. Could be as simple as isolation, or it could also include encryption as well. So all of these things make up the challenges that come with WVD service even after it gets deployed.
Great. Yeah, that makes a lot of sense. I can totally see those as being real world challenges. What about visibility? I have a lot of customers asking me about visibility. Is that a challenge as well in here?
It can be, for sure. Azure does have some tools that are available to provide some visibility into these traffic flows. However, they tend to be spread across various tool sets. One of the nice things about Aviatrix and the visibility that we bring with Copilot is we can centralize that all in a single pane of glass.
Yeah, exactly. If you guys haven't seen my videos about Copilot, go check it out on the YouTube channel. I have a lot of them there. It's a very impressive product, and we just keep making it better and better with every release. And I'll have a new video out soon about some of the new features that we just deployed. It's really exciting. So, Manny, anything else you want to add to this around challenges?
Yeah, to add to what Bryan was saying, so these desktops, right? Like being in a VNet, they have the VNet default behavior. So if security is really important, right, you have to manage the connectivity and the security. That means you have introduced, security appliances that might be, firewall, proxy, whichever it may be.
Mm-hmm.
That also requires, UDR management on the VNet.
That's right.
Which can which can become cumbersome, specifically if you have a lot of them, a lot of different directions where you want to steer traffic.
Yeah, so just like I thought, quite a few challenges, and I'm really curious to see what Aviatrix is doing to solve all of these for our customers.
So if we look at the Aviatrix design here, you can see that we've got multiple things going on here. So now we've got a transit connected not just from Azure, but also giving access to applications in a different cloud.
Mm-hmm.
And if you add our feature, which is called FireNet, which allows us to deploy and orchestrate third-party firewalls like Palo Alto, Checkpoint, seamlessly inline and route traffic through them. Now we have the ability to secure the host pool traffic, mm-hmm. not just to the internet or to on-premises, but control plane connections, right? As you can see, these desktops have to access that managed side of the solution.
Right.
So we secure that as well. And that also gives you the visibility that they wouldn't have to begin with. And then if we have, which I have had customers that have requirements to access applications in a second cloud like Oracle, like AWS, we can provide that transit, seamlessly deploy gateways in a different cloud from a central point and provide that encrypted connection from a one cloud to another one. Not only that, we can provide the security segmentation. So if you see how I color coded it, mm-hmm. The VPCs and the VNets, what that means is the red host pool needing to access an application in AWS could do it securely, and we could do it through multiple host pools as well. So we have the ability to securely isolate those host pools and secure the connections, encrypt them, and route the traffic to different application pools on a different cloud.
Yeah, and it looks like you also can do that segmentation to on-prem, right? Not just from cloud to cloud.
That's correct. So, if you have, whether you have ExpressRoute or you have a VPN connection, right, we can extend that, not just the segmentation and the security to on-prem, but also to a second cloud. And one of the most important features or capabilities that this design brings you is visibility. Now we have the ability to see all inbound and outbound traffic from those host pools to whichever destination. Not only that, we can see it in a central place, a single dashboard that not only can show you the point-to-point connections, IP to IP connections, but can also dynamically build a topology for you and also show you all of these events that are happening in your network. This is actually called Copilot, which is a VM that we can spin up in conjunction with a controller.
So one other thing I wanted to add that I think is very critical here, one of the challenges I mentioned before was the need to also interact with native Azure services. And I think this is a key differentiator for Aviatrix, mm-hmm. is that we're not simply just an overlay. So for those host pools in this diagram that are connected to Active Directory domain services, we're unable to put a gateway in those spokes. But that's okay, because the Aviatrix is able to speak Azure native, mm-hmm. and so we can instantiate a native peer directly from the VNet that hosts ADDS and connect them directly to the host pools, so those host pools can join the domain. A second key thing is the fact that Aviatrix is controller-based, and so what that allows is for visibility into the entire multi-cloud environment. Now, why that's important is because once we set all of this up with things like FireNet or multi-cloud segmentation, these environments tend to not be static. They're going to grow, they're going to change. But because our controller has visibility into that end to end, it can make sure that our security posture from a routing perspective stays correct, even as the environment grows and scales.
Yeah, I can see how powerful that is. I mean, we have customers leveraging that core functionality of the controller with all our solutions, all our use cases, and it's super powerful to have the visibility and the control, the deterministic nature of the controller, and just the intelligence and logic injected into your network that just doesn't exist today in cloud networking. It's so basic, so rudimentary. We really augment the intelligence of cloud today, which always blows my mind. So I'd imagine that if we're dealing with many users, enterprises that have many users that need access to WVD, there's also going to be a lot of host pools and many hosts within those pools potentially. So how does Aviatrix handle the scale out architecture?
So the beauty of the Aviatrix solution is that from the same controller, we can grow the gateways. So if there's more capacity required, we can grow those gateways from the controller. Not only that, if obviously if traffic is growing and we need to scale out that FireNet function, we can do that as well. We can spin up, more than 2 firewalls, 3 firewalls, like I'm showing in that example. So it's pretty powerful. We can pretty much scale out the whole solution, including security.
Yeah, and our controller is intelligent enough and our gateways are intelligent enough to look at that traffic, create a hash, and then load share that traffic across all those firewalls. So we can scale out to some pretty high gigabits per second, right?
That's correct. We can choose from any number of flavors that are supported, not just in Azure, but AWS as well. If I could boil it down to what we bring and our value here is the fact that we bring some incredible security functions and features, okay? We provide the transit connectivity, we provide the visibility, and it's all done from one central controller. Not only that, we can automate all of it with Terraform.
Perfect summary, Manny. Thank you very much. I want to mention that this design and this solution is going to be a part of one of our Aviatrix validated designs. We're working on a bunch of these, and what we're doing is taking a lot of the challenges that we see in the real world and that we're solving for and putting them into validated design guides so that you can consume them easily. So you'll find those on aviatrix.com or docs.aviatrix.com very soon. So keep looking for those. I want to thank Manny and Bryan for your time. This has been incredible. Thank you so much.
Thanks, Dana.
Thank you.